Deep in the Amazon basin, beneath the lush canopy that has sheltered life for millennia, archaeologists made a discovery that would quietly rewrite soil science. Scattered among the thin, poor, blood-red soils that characterize tropical regions, patches of impossibly dark, rich earth. They called it terra preta, dark earth, and in it lay a secret thousands of years old. That secret is biochar, a carbon-rich, highly porous solid produced when organic material, wood, crop residue, manure, is burned in an environment with little or no oxygen. The process is called pyrolysis, and the result is a material that looks like ordinary charcoal but behaves like nothing else in the soil science world. Zoom in to the microscopic level and you'll see why. Biochar is riddled with billions of tiny pores, a structure so complex that a single teaspoon of quality biochar can have the internal surface area of an entire football field. Pre-Columbian peoples in the Amazon were not soil scientists by training, but they were exceptional observers. Between 500 BCE and 1500 CE, they transformed thin tropical soils by incorporating charred organic matter and organic waste, creating terra preta deposits that still outperform surrounding soils today. 2,000 years later, Dutch researcher Wim Sombroek stumbled onto these dark patches in the 1960s and spent decades trying to understand what made them so productive. His work laid the foundation for modern biochar research. The carbon locked inside those Amazonian soils hasn't degraded. It's still there. And that stability, that refusal to break down, is what makes biochar one of the most exciting tools in agriculture and climate science today. Modern biochar production starts with a feedstock. Virtually any organic material works. Wood chips, rice husks, corn stover, poultry manure, food processing waste, even sewage biosolids. That feedstock is loaded into a pyrolysis kiln and heated, typically between 300 and 700 degrees Celsius, in the near-complete absence of oxygen. No oxygen means no combustion. Instead of burning up and releasing all its carbon as CO2, the material transforms. Higher temperatures produce biochar with greater surface area and stability. Lower temperatures retain more nutrients. The art is in the balance, and the result is a material engineered for the soil. Quality biochar is certified by international standards bodies. Look for IBI or EBC certification to ensure safe, consistent application. So what does biochar actually do when you put it in the ground? Physically, it opens up compacted soils, dramatically improving drainage in clay and water retention in sand. Studies report water holding capacity increases of 15 to 25% in sandy soils. Chemically, those pores act like sponges for nutrients. Calcium, magnesium, potassium, cations that would otherwise leach away in heavy rain, cling to biochar's charged surfaces. Cation exchange capacity can increase by 20 to 40%. Biologically, inside those pores, microbial life explodes. Bacteria, fungi, protozoa, they colonize the labyrinthine structure of biochar and stay. Mycorrhizal networks establish faster. Earthworm populations increase. And for the climate, every ton of biochar applied sequesters carbon for centuries to millennia. It also measurably reduces nitrous oxide emissions from soil, a greenhouse gas 270 times more potent than CO2, by 30 to 80% in some studies. From the field to the city, biochar is finding its place. Farmers in tropical regions have seen yield gains of 10 to 25% in degraded soils. Horticulturalists blend it into potting media. Green roof designers use it for water management. Water treatment engineers deploy it in biofilters to capture nitrates and phosphates. In remediation work, biochar is showing real promise for locking down heavy metals in contaminated soils. Lead, cadmium, arsenic, bound to the carbon matrix, bioavailability drops sharply. And in the livestock world, biochar added to animal feed reduces methane in ruminants. Mixed into bedding, it cuts ammonia and pathogen load. Added to manure compost, it slashes nitrogen loss. Biochar is not a silver bullet. Results vary by soil type, feedstock, and application rate. Alkaline soils need different strategies. Certification matters. But as a tool for soil regeneration, carbon sequestration, and sustainable agriculture, the science is compelling. 2,000 years ago, indigenous farmers in the Amazon figured out something remarkable. We're only now beginning to fully understand it. V/O. If you want to go deeper, the full breakdown, application rates, and soil science data are in the description below. And if this kind of content moves the needle for you, subscribe. There's a lot more where this came from.